about the relationship between differentiability and continuity and differentiability in general. Alright, in our past videos we gave you equations to differentiate a function, and this is just another way to write it. F prime at c equals the limit as x approaches c of f of x minus f of c over x minus c. Okay, so for this equation to work, the limit as x approaches c has to be the same from both the left and the right. So let's look at this first graph right here. The limit as x approaches c from the left and from the right on the interval ab exists, and the point at c is defined. So we can assume that this graph, this function on this interval is differentiable. However, if we look at this step function right here, as the limit as x approaches c from the left and the limit at x approaches c on the right on the interval ab, those two do not equal each other. So even though c is defined at this point, it's the limit from the left and the right do not equal each other as x approaches this point, so we can assume that this is not differentiable. Now, differentiability and continuity are related in the sense that if the function is differentiable at x equals c, then it's continuous at x equals c. It's possible, however, for a function to be continuous at x equals c and not differentiable at x equals c. For example, let's look at this absolute value graph. The point at c is defined, and you can see just by looking at the graph that it's continuous. A derivative is just a slope, right? So right here we have a negative slope, and over here we have a positive slope. So we can assume that the derivatives aren't equal to each other, and therefore these do not equal each other from the left and from the right. So this is not differentiable, even though it's continuous.